Welcome to an introduction to quality control design. This video is based on a presentation by John Yunt Pacheco. The presentation summarizes the results of the work from a number of distinguished scientists. We would like to acknowledge their impact on the field of clinical diagnostic quality control. Quality control in clinical diagnostics would be much less advanced without their contributions. Let's consider two scenarios: creatinine kinase and sodium. Do these two analytes need to be controlled the same way? It's generally agreed that creatinine kinase has a quality specification of plus or minus 30%. The quality specification of sodium is much tighter, generally less than 3%. If we produce creatinine kinase and sodium results that are both 5% above the expected value, which would we be more concerned about? The sodium, of course. In this scenario, we need to control the sodium values more tightly than the creatinine kinase values. The process of determining how we should best control each analyte is called quality control design. More precisely, quality control design is the process of identifying what quality is needed for each test and what control rules are required to notify the laboratorian if the quality specification is not being met. This is a cost associated with ensuring quality. We want to ensure that we meet our quality specifications, but not waste money and effort on trying to improve tests that already have a sufficient quality. If our quality specification for creatinine kinase is plus or minus 30%, and our creatinine kinase test performs with a quality of plus minus 2%, we don't need to worry about improving creatinine kinase. We should instead focus on other analytes that are not in such good shape. Identifying appropriate quality specifications for each test is not enough for determining how we should control each test. We need to also consider our test performance. Going back to our sodium and creatinine kinase example, if our sodium results have a variation of 0.25%, but our creatinine kinase results have a variation of 25%, we'll need to control our creatinine kinase test more tightly than our sodium test. There are 3 steps to designing the quality control system for a test. First, we identify what's the appropriate quality specification. Then, we evaluate our test performance. And finally, we select quality control rules that are appropriate for our performance and quality specification. Determining what quality is appropriate for a given test is not an easy thing. There's been a lot of debate around the world about appropriate quality specifications for clinical diagnostic tests. A conference was held in Stockholm, Sweden to address this. Which types of quality specifications were more preferable than other types? The result was a hierarchy of quality specification types that can be used to determine the relative value of a set of quality specifications. Those at the top of the hierarchy are preferable to those at lower levels. For all of your laboratory QC needs, go to www.qcnet.com.